center is located in the neighborhood of Munich in Garching, and it has 200 square meter indoor space. And in this facility, we have two different platforms here: human-robot interaction and cooperative manufacturing station, and electric car testbed. And we have one more additional station, which is located in the city center. And here you may see all of our facilities here: cooperative robotics manufacturing stations, microsurgical robot, and electric car testbed. I would like to start with the manufacturing station. It's equipped with tactile Sapphire flow for human tracking with laser scanner and camera-based workspace monitoring. The setup consists of several robotics arms such as Stovli, ABB, KUKA, and Mitsubishi Robot, and with an end effector and a mock-up of a collaborative manufacturing site equipped with a tactile Sapphire floor. The environment can be easily configured to represent different variations of the manufacturing, and we mainly use the KUKA robot here, which has 7 degrees of freedom and each equipped with 2 torque sensors, and its maximum reach is 82 centimeter and maximum 14 kilogram payload, minus the weight of the gripper, of course. The gripper that we have here, KUKA R800, it has 2 parallel fingers with a maximum force of 150 Newton. Both the arm and the gripper are certified for collaborative use. And on top of, there is an Epson projector on the ceiling of the work cell with a maximum resolution of 1920 to 1200 pixels. We also have a Kinect version 2 mounted on the top of the work cell, and the pressure of the floor is measured by 40 to 40 tiles and represented as a value between 0 to 1044, 24. And the recommended way to use these robot arms with ROS, which is integrated with all our hardware. And we have a full simulation of the robot arm in Gazebo, and we have Hoyuk-sen's laser works also well with Gazebo. As I told you before, our preferred option is ROS, and it can also work with MATLAB, and also it's possible to control with the KUKA Fast search interface. It's also fully integrated with MoveIt, and also Kinect might be used with PCL or OpenCV. We also have augmented reality and Flexby integrated with the workset, and also there is, unfortunately, we don't have any lab technician. We are asking our PhD students to help with our visitors. The platform can be, this installation is particularly useful for the research on human-robot cooperation, multi-robot object manipulation, human tracking, and detection for ensuring safety. I also would like to show you a video from one of our previous projects. It's from the horse project, and we had a demonstrator here.
Esra, do you hear me?
Yes, I can hear you.
I think there is some problems in the transfer of the video. Can you comment a little bit
Oh,
what we
okay.
see?
Okay, in that video is from one of our another projects, and for that one, there is a AR system which shows, which detects the problems in the component, and with the help of the system here, it helps the worker to understand the, let's say, broken or not in a good shape, and then it can, if it is in good order, it can go to the where they can discard the parts. Maybe
Do you hear me?
maybe I should continue.
Yeah.
Yes, I can hear you.
Okay. I think it's better to cut the video because yeah, it reduces the capacity of the channel.
Okay, then I just removed that, and maybe I should continue with the other platforms that we have here. I mean, actually, I would like to show some video from the TERRINet visitors, but unfortunately, it's not possible now. Then I will continue with the other platform. The second platform that we have for TERRINet is electric car testbed, which consists of four control drives directly connected to the axis of the rolling roster electric car, both with the car drive and other components, as well as the external torque applied to the axis can be controlled. And the station can be used to simulate desired driving conditions and evaluate the performance of the wheel drive control algorithms in fully controlled and reproducible environment. And as you see here, it can consist of two different parts, which is the engine and vehicle testbed. And there are four inverter modules from common DC link feed and regulations for the testbed is speed control, torque control, and driving load simulations. And it has maximum weight 2,000 kilogram and wheelbase of 1.2 to 2 meter. And mechanical compensation of the steering angle and tire drop over stable articulated arm construction and support bearing. And the steering angle is 18 degree and direct connection to the wheel hub thus highly dynamic measurement makes the highly dynamic measurement possible. And possible applications for this electric car testbed is different level of abstraction from low-level controllers of the car component up to driving, monitoring driving control of the entire vehicle. And it's also possible to analyze the human behavior with this platform. And the last platform that we have is microsurgical platform, which is a setup that originally designed and developed for the ophthalmic application. It can be also used for other medical and biological procedures, and it could be used as a training platform for micro-robotic applications as well. And it's quite lightweight. It is 315 grams, and it has a high precision, which is around 10 micrometers. Open access software platform can be used for that, and it has a haptic interface. It has 5 degrees of freedom, and it has a USB interface, and it has a 5 ampere peak power, 12 volt at 5 ampere peak power supply, and integration of imaging devices and microscopes to the setup enables platform interdisciplinary projects such as image-guided micromanipulation or some applications like that. And that's all from our side. And from the first call, we have two proposals are accepted for TUM, and one of them is the first platform, and the second one is for the electric car testbed. And unfortunately, we haven't hosted them yet, but hopefully we will solve our problems very soon and they can come here. And that's all from TUM's side. And if you have any question, please feel free to ask. Can you hear me?
Okay, yeah. Thank you very much for your presentation. Are you able to describe a little bit the kind of training support that you could provide to users attending the platform in terms of introduction to the hardware and the software?
Actually, I have to discuss it with my colleagues, but currently unfortunately, we don't have any training option now.
Okay.
Because maybe we mentioned before, nowadays there are some problems with some platforms and we are trying to solve that issues.
Okay. What I was saying is that initially in TERRINet, we decided to have kind of winter school or summer school.
Yes.
But it's difficult to plan that because we don't have a real audience for such school. So we decided instead to provide to users that attend the different platform some transfer of knowledge, some training courses about that are technical, that are focused on the platform.
Okay.
So I will send you a document on which maybe you can summarize all the information, and so I will give you the what we are expecting in terms of information exactly.
Okay, that will be perfect if you could forward it to me. And also, I mean, I'm not sure if it's in the scope of the trainings or not, but for example, last year we organized a workshop in International Vehicle Symposium.
Okay.
That is on intelligent vehicle applications, and we organized it in the name of TERRINet.
Okay.
And this year we also submitted the same, submitted another workshop to the same conference, and if it will be accepted, we will also use TERRINet names for that workshop.
I think you have to discuss about that with Rosella and Paolo, maybe to know exactly. Yeah, we discuss of the possibility to have some grants for students attending some events, but I don't know. It will be difficult because normally a grant is only for going experimenting on the different sites.
Okay, I see.
Okay. Do you have any question for Esra? Technical questions about what she presented? Okay. No. So we thank you again for your presentation.
And thank you for your time. And I'm really sorry that we couldn't be there today.
Okay. So we will probably organize a similar meeting next year in Imperial College in London. So we hope you can join. And also we will have an event in ERF in Malaga and in ICRA in Toulouse in next June. In Paris, I'm sorry. So thank you very much. Bye-bye.
Can you hear me? Philippe?
What did you say?
Can you hear me? I can't hear you.
I didn't understand what you say. Esra?
Yes.
Yeah,
Sorry, I couldn't hear you. Can you hear me?
Yeah.
Okay, great. I was saying that me or another colleague of mine will definitely join ERF and also our next meeting in Imperial College.
Okay. So see you there. Thank you. Bye-bye.
See you.